Chapter 4 is all about congruent figures. First definition: two polygons are congruent if their corners can be matched up so that the corresponding sides and angles are equal. The order in which corners match is a very important key. Do the polygons below seem like they might be congruent? No, unless you're given more info or actually measure stuff, you can't tell for sure, so just never assume that they are. So looking at the polygons, I see alongside alongside a shorter one, a really short one, a middle length, and a little smaller. So I would say that this one, AB, lines up with this. And then now I know it has to be HI and AE because next along is ED. So I'm just putting little dots, and then this one would be the next one, and then the last one would be LK and BC. So when you line up these, it's important that they match. So if I start with polygon A, B, C, D, E, I must match A with which angle, which corner? Well, I must match A with H. And then I would match HI with AE. So basically we go around until we match up all the vertices. So HIJ and then KL. And congruent symbol is squiggly with an equal sign under it. So that is the proper matchup of that situation. Okay, example 2. Now in each problem below you are given that two triangles are congruent, but the way the sides match up may change in each. Very carefully find the unknowns. They tell you ABC is congruent to DEF. Okay, these are lined up, so it's going to be not so bad. Okay, find X and Y. Well, let's see. Angle F matches up with angle C, so that's 80 degrees. Angle D matches up with angle A. Oh, so angle A is 30 and angle D is 2x, so we can solve for x to get 15. Angle Y matches up with E, but we don't seem to have enough info. But yes, we do. We know that this is 15 degrees, and so 80 from 15 is 95, if I did that right. 80 plus 15 is 95. So this has to be 85 degrees, right? It's the leftover. So we know that 85 has to be, let me make sure I did this right. I think I did this right. 85 equals y minus 10, so y equals 95. And those are the two answers for example 2a. Now, triangle ABC and triangle DEF. Notice this is a little turned around. So we only have to match up side AC, which is here, with side DF, which is here. Not 14. Can you see that? AC is here and DF is here. And again, if you look at the lineup of the script, it'll help you. So we're going to solve 2x equals 12 to get x equals 6. Now let's handle BC. That must line up with EF. BC is 10 and EF is y plus 2. So y must be 8. And the last is AB, and AB, which is the bottom here, lines up with DE, which is the side here. So 4Z equals 14, or z equals 14 over 4, which is 7/2, which is 3.5. Z is 3. Oh, I see, I can write it down here. Z is 3.5, y is 8, and x is 6. Okay, any questions? Ask in class. Next problem. Triangle ABC congruent to triangle DEF. Find x and y. So I think I'm just going to help walk you through the setup and you finish the algebra. Angle A lines up with angle D. Angle A and D. Well, there's not enough information. Just deal with that right now. Angle B lines up with angle F. Oh, angle F is 45 degrees. See that? Angle C lines up with angle E. So we know 85 equals 2x plus 5y. I'll try to make that a little bit neater for you. Change the color, make it happy color. Not that purple's not happy. Okay, we have 85 equals 2x plus 5y. That matches up C with E. And let's see. Well, this is 45. This has to be 85. What's 85 plus 45 is 130. So this angle has to be 50 degrees because of some of the triangles. Angles are 150. So we know that D and A have to match up. So this is a system, and you must solve this. 4x minus 2y. So finish this, maybe pause the tape, and then keep going. Next page, section 4.2. In last class, we cut out triangles and try to figure out which triangles were congruent given one thing or a couple things. If you have one side of a triangle congruent to another side of the triangle, is it necessarily true that the triangles are congruent? We found in class that if you have two sides congruent, or one side on each, there's no congruence overall. If you had two sides congruent and the third side not, we found there were no always congruent. However, if you have a side and the included angle, see how A is in the inside? That's included in the middle. And then a side congruent to a side angle, side congruent in another triangle. This was proper. This is a bad word when you respell it or reorder the words or letters, but in fact it does not always true. That's one way to remember it. This one, this is the included side, and when we did that activity we found out that that was a good one. Angle, angle, angle did not necessarily hold true, and side, side, side did. So the three new facts are below. Side, angle, side. This is side, angle, side, triangle congruence. If two sides and the included angle of one triangle, are congruent to two sides and the included angle of another triangle, then the triangles are congruent. That will always hold true. Congruent to two sides and included angle of another triangle, then they're congruent. Second congruence of triangles we found, the ASA, angle, side, angle, triangle congruence. Two angles and included side of one triangle congruent to two angles and included side of another. Then triangles are congruent. And the third triangle congruence so far is side, side, side triangle congruence. Three sides of one triangle congruent to three sides of another. Then the triangles are totally congruent. Triangles congruent. Let's try looking at the bottom and proving this. Given AC bisects angle BAD, to bisect means to break up, and angle BCD, which means angle 3 and angle 6 are congruent. Prove the triangle BAC is congruent to triangle DAC by one of the top reasons. So in the interest of time, I'm going to have you write the given right here. Don't forget to write the given in the first step. To be bisecting means angle 1 equals angle 4 and angle 3 equals angle 6. And that is the definition of bisect. So to show these two triangles are congruent, we have to either use SSS, which we just talked about above, SAS, or ASA. So I have two angles in one triangle and two angles in the other. So if I can show that the middle side is congruent by reflexive, then we've proven it. So this is a 1, 2, 3, 4-step problem. Triangle BAC is congruent to DAC by reason of angle side angle congruence. So example 4 asks us to examine these pairs of triangles and decide if they are congruent by SSS, SAS, or ASA. And if I look at the top one, you can see it would be yes, they're congruent by angle side angle. Angle side angle. See that? This one, you have these sides congruent, these sides congruent, and the third by reflexive. So it's side, side, side. And I'd like you to finish these on your own for practice, and we'll discuss it in class tomorrow. I know the notes here got a little messy, but if you look in chapter 4, it will have the definitions there as well, and I can help you. If you've done this in pencil, we can write on the board next class.